All right, so here we go. Let's check that the stream is working. Let's get started. Okay, that all looks good and well. All right. Welcome everyone. Today I'll, oh wait a second, I guess the YouTube description is wrong at this point. But I won't be working on the REPL today. I'll actually be working on setting up a benchmark suite. So let me change that really quickly. So, work on PureScript's pile basically. Yeah, so I'm gonna, oops. Okay, so let's see, has that been saved? Okay, so saved. Okay, so I should put the link in here. Okay. I'll put it in here as well. Okay, so, and if anyone wants to ever, like, get my attention, just mention me on the Slack channel and I should be pinged. Okay, that all looks good. And here I am. So I've got, well, I managed to, after weeks of struggling with it, finally setting up an Arch system which runs Linux which runs Haskell properly again. And what I'm going to do is I'm going to try and create a directory in the PureScript compiler here, which uses PSC package to install a set of packages that builds with the current like master, because not all the packages do, because there are some breaking changes in there. But I'd like to benchmark the current master because I'm working on making some changes to that, so I need to know the impact on the performance of that. So that's why I thought, for one, I'm gonna create a branch here. Oops. So let's just, damn it. What am I doing? So I'm gonna make a branch. I'm gonna call that PSC package, benchmark project setup. I don't know. Whatever. Okay, so I'm gonna call it's inside. Did we have a tests directory? So I'm gonna call benchmarks directory maybe. Yeah, I'm gonna make a project directory here. It's a bit of a weird name, but I don't care. Now I'll create the PSC package JSON file in there. And okay, so here I am. And I will copy all the stuff we need to make a PSC package JSON. This one, yes. So I'm just going to call this project. That's probably wrong. Okay, so this is 11.6, I believe. Let's just make sure. So the packages, package sets. Okay, over here. So releases. Okay, so let's pick this one. Right, that don't work. Huh. Copy, paste. Okay, now works. Okay, so we're going, and this is the package sets we're going to. Okay. And okay, so depends. Okay, so that looks good. So over here, if I go into that directory now, project, I should be able to do a PSC package build. Okay, and so that does, and like insert the prelude, or like download the prelude and properly compile it. Okay, so that's good. So we have the prelude, but like I said, I want more. So let's see how good my editor skills are. I'm gonna put these in there. And let's see if I can do this. Does this work? Nope. Okay, so I need to break this into new lines, obviously. So maybe I can make a macro which does this. So I'm gonna record a macro here. Okay, so I'm gonna find space, gonna break, I'm gonna, okay, so let's try that for a second. Okay, so that worked. And now we need to do that a bunch of times though. So I'm going to make another macro, so find space, break it down, find space, break it down, find space, do this. And I think that's that, so yep. And I'm gonna do this. Okay, here we go. And now I need to, of course, wrap all of these in parentheses. So I'm gonna make a new one. So, oops, like that, and then just go to the next slide. Right? Okay. And now let's do that 20 times, 30 times, another 20 times, and just one more time. Here we go. Okay, so that looks good. Right. Oh, we need to get rid of all the PureScript's in here. And I want to prefix it with commas anyway, so I'll just do this. So Control V, I'll go down 60 lines from here. Like this, that looks good. And then we do comma, and I want only a single one, like this. That's gonna take a second. Okay, here we go. And now we just move all of this into here. We fix the indentation of this. There we go. So I'm hoping that this will build. So avar does not exist. Avar. Huh. Okay, so let's refresh this. Do we never have avar in here? Huh. Well, I mean, we could start to make our own package set and start adding additional packages, but for now I'm just hoping I can get by. Okay, so that worked. So only avar, which I think might actually not exist anymore. Okay, so that worked, and we compiled all this stuff, and I mean that didn't seem to be a whole lot actually. I was expecting a lot more package like modules in there, because that's like a lot of packages. Where are all the data function ones, for example? Well, that's how we get. So output. Okay, so how do we ls output? Do word count or something? Is that a thing? 307 modules. That's pretty. I think that's how that works, right? What happens if I do -1 and then I count the lines? Yeah, 307. Okay, so it's 307 package modules in here, which is not huge, but it's also not nothing. Okay, so I have a thing in here. So how would I go about benchmarking things here? I'm gonna create a file. So let's start by just saying that we've added a do I need to set the email address? I think I need to do that. How does that work again? Come on. Git config -- global user email or something. I need to set it to something, of course. So use this one. So does that work now? Okay, here we go. So add a PSC package .json project file for benchmarks. The benchmarks? Yeah, for the benchmarks. Okay, so we have that, and the install process works. So now let's try to see if we can not create a benchmark. So let's do a simple one first, I think. Let's just try to get something going first, and then we'll see if we can do something better. So I'll do a bench.hs file in here, and that might end up being a main file instead. I'll see in a second. I'm just going to use Criterion for this. I'm going to check the chat really quickly. Alright, it's all good. Seems to work fine. Yes. Okay, so Criterion, yeah, we want a Haskell benchmarking tool, please. Here we go. A Criterion tutorial. I think this is the right one. Okay, here we go. So this is kind of what we're going for. Let's just put that in here. Okay. We don't care for the charts really. We want something with I/O especially, because we need I/O stuff, I think. Well, maybe not actually. Okay, so let's find out how to make a stack benchmark. I think we actually want HPEG for that. So HPEG benchmark. Okay, so let's find bench in here. Benchmarks. See benchmark fields. Okay, so benchmark fields, main, other modules. Main and other modules. Okay, so what do? We go into our package.yaml file, I think. We have executables, tests, so let's add benchmarks. And I'll add the IDE benchmarks or something. Right, and main is bench.hs. Source this, which I believe we still need. So source does benchmarks and dependencies. I'm not sure if these can have actual dependencies, but I'm going to add Criterion anyway. And we'll see how this goes. I'll still give us some results here. So let's see what happens. Yeah, I'm sure we'll put an error here. I definitely need to kill this error. How does that work again? Error not restart. I don't know. We can try to kill it and see if it restarts. Maybe we should just. Maybe we should just try building it. So stack bench, I believe, is the command. So, okay, so if I want to start adding criteria, that's a nice one. So that seems to work. That's a bunch of dependencies. Holy crap. It's because of all the reporting stuff that it does with the graphs and CSV and all that kind of stuff. Okay, so that works. Well, while that's working, I'm going to look at more of the documentation for criterion. Okay, so regressions. Dash dash regress. How does that work? How does that work? Okay, so we're going to do more of that. I think what we want is like some kind of setup IO, which does make sure that we've downloaded all the library stuff before we go into benchmarking. Benchmarking. How to write a benchmark soon? Huh. So yeah, and I mean we also kind of just need to think about what we want to do in the first place here. But this seems to build an awful long time. Oh my. Haskell, Haskell, Haskell. Okay, so this is fib. What do I do with this? So let's just try to make a plan for once. So step one, I want to make sure to update all the packages. And then two, at least for the PSCID test, which are the ones I'm trying to build right now, I want to make sure to compile all the packages. And then what I'm going to do now is I'm just going to load all files without source logs. And then I'm going to load all the files with source logs, just to get an idea of how long these things take in the first place. Okay, and there it goes, and that's going to take forever. So let's just stub these out, right? So update packages. It's probably just going to be an IO. Look at that. We might need to use one of the Haskell shelling libraries to make this a little nicer. So update packages, compile all the packages, and I have some code in the IDE test suite, which I might be able to use for this. I'm just going to make them do and then I'll find that stuff. So that is IDE test, I believe. So this is delete output folder. That's kind of boring. But this is the part that we care about. So what does this do? Create a process, shell, and then it's going to here. we just shell out to PureScompile, and this will get a different source glob because I'm using PSC package here. Might be worth thinking about using it as a library. I'm not sure if that's an intended use case. I don't think it is. No, it does not even have a lib. Okay, so then we're not going to do that in that case. And we'll see if we can add a few more packages to the set that's still build master. And we'll have to figure out a strategy, because I mean they are going to be breaking changes on master and we still need to test it, so we kind of need to find a way to build like a compiler specific package set which can have patches applied to it. I will see in a second. We'll see how that goes. But I mean, this seems simple enough. I'm just going to copy this and we'll see. And I think we also need this in project, basically. Just that it's going to go to a different directory. This is not going to go to tests, this is going to go to benchmarks project. Okay, and so that's all that. Okay, so yeah, it gave me a mismatch bracket error, which is correct because this needs to be closed. And now this is giving an error. Criterion main, yeah, don't care about that. Okay, so we're actually compiling that one now. I'm just going to copy all of this. I'm not sure if I need all of it. Gonna do so anyway. Okay, we'll try again. See what we get. Okay, so exit code is in none of these. Wait, what? Where is exit code coming from? Where is that coming from? System.exit. Well, I guess the preload re-exports that? That's a bit weird. Okay, so yeah. Now I'm already growing tired of this, so I'm gonna do language. No, well, let's actually do a capital language because we're doing that in the rest of the code base as well. So I'm going to say no implicit prelude, and then I'm just going to import the prelude. And at some point we want to write compile specific prelude because prelude does have a bunch of stuff in it which doesn't really work well. And there's an error somewhere in here. Negative. I didn't care. I think it's called panic. So let's go for that. And we need overloaded strings. Okay, up was redirected with, oh, but no output will regenerate because it was a main module. Okay, so it turns out we kind of need to call this main apparently, so let's try it again. Okay, now that is running a benchmark. So that's pretty good. Nice. Here we go. There we go. Okay, so that's looking good. Alright, so we have something that actually does benchmark. So I'm not sure if I want to commit the fib function though. but I think I still want to, just because that actually means that we set up stuff. So set up benchmark. Oh, that's a bit of a broad message. Set up benchmark suit. So runs. Can be run with static bench. Okay. And yeah, that's just, that doesn't really matter. Okay, so that looks good. So let's get rid of fib because we don't want to actually benchmark fib. We'll call this benchmark group IDE. Bench looks good. I'm gonna do with source globs. Right, and then we're gonna say, oh, sorry. So yeah, so with source globs, and this is actually the one without. Don't care about these. And here I'm gonna do the thing where I actually like load the thing. But now, before I do any of that, I need to just get my parents in here. I need to compile the project. Right. So let's do that. So let's do in project. Well, let's actually do the compilation in project, not everything. So in project, we're gonna do compile project. Compile test project is a bit of a weird name. So compile project, and that's actually gonna be PSC package build. And I'm gonna maybe use the proper resource spans there at some point. So that should work. Compile project, right? That's gonna give us back a boolean to tell whether or not this worked. So let's do when. Well, we kind of want to know when this fails, right? So let's do compiled. Then we'll do if compiled. As compiled. Then we're going to do the benchmark stuff. This bit. And else, we're just going to panic with test the benchmark project. And at some point we want to benchmark that actual compilation process. But yeah, I'm working on the IDE stuff for now. And then if that works out, we can benchmark the other stuff as well. Okay, so let's just make sure that this the compilation stuff works. There we go. So fib, yeah, this is not doing anything anymore. So I'm just going to do 1 and 5, which doesn't matter. Right. Can make sure benchmarkable. Okay, so this needs to be a function. So let's do ID. Does that work? Doesn't work either. I'm gonna do const 5 or something. Const 5? Does that work? I don't really know. I think we can also just use IO stuff, which is like just pure unit. Okay, so let's figure this out. Enough poking at it. Benchmark in an IO action. Bench NFIO. Okay, so let's do NFIO. NFIO for pure unit. Pure 5, whatever. Doesn't matter. We don't actually want to benchmark anything, we just want to think about it. Okay, so that seems to be fine. Ambiguous type variable, oh, come on. Yeah, that's an int, if you want. Oh, I'm just going to use unit. polymorphic literals. Annoying. So system exit is okay. So here we go. System exit is redundant. Benchmark / project change working directory does not exist. That's true because, well, I need to run this from here apparently. That's a little bit of a bummer. Maybe I can use some way to do this properly. Benchmark / project does not exist. Well, that's interesting. Benchmarks / project. Well, that does totally exist. But does that work? That would be silly. No, that doesn't work. So benchmarks / project does not exist. Well, just give me the current directory then. So let's do that really quickly. Let's print out current working directory here, just so we get an idea what's going on here. Okay, so it's, oh, well, compile project already used in project. Okay, let's not do that then. Yeah, that's true. Of course, that's not going to work because, yeah, okay. And of course, this is a bit silly now. I mean, it ran updating 71 packages. Sounds alright. So what I'm going to do now is I'm going to just nuke the output folder here. So I'm going to go into benchmarks project. I'm going to delete the output folder. I'm going to run stack bench again. See what I get this time around. So first compile no files using pattern, and that benchmarked the entire thing. Couldn't compile the benchmark. Okay, so this takes too long apparently for it. And I mean, it does finish eventually. So what do we do here? I could bump this number. That's a bit weird. I don't want this to be flaky. But I don't think it's going to complete. Right. Yeah, so I'm just going to bump this to 20 for now because that's fine. It's going to be fast enough if I do that, I think. Benchmarking IDE without source code. Okay, so there we go. So that looks good. I'm going to leave this as it is. I'm going to think about whether or not I want to clear the output folder before it, but I don't think I should. No, I shouldn't, because I'm not going to change anything in there. Okay, so we do have this stuff. So updating and compiling, yeah, we do that by just calling compile project, which does the thing we care about. So we don't care about that one. And so let's actually look into building the bit we need to benchmark the IDE code. So how do we do that? I'll need to look into my IDE test code again. Well, before I do any of that, let me just make a commit here because that seems fine. So how's the benchmark project before running benchmarks? Yep, that looks good. Okay, let's just check if anyone has any questions. Oh, looks good. Okay. So, what is the idea here? I want to go into my test files because I do have a run IDE here which takes the IDE configuration and IDE states, does all that stuff, and there's a less, like an easier version of this. But I think I'm gonna need to pass the globs because that, yeah, I don't want it to find anything actually, so that's good. Okay, so let me, I don't know if I can depend on this stuff from here. Is that fine? Like, can I make the benchmark suit rely on the tests? Okay, so you can add PureScript as dependency, but I want to add, yeah, so it says dependencies PureScript. Yeah, I mean, I can do that. But I want to actually rely on the test suite. Does that work? Let's find out. Let's see if there's anything in here which might help. So all these are benchmarks. Build depends, and they all depend on the local one. Well, I guess I could add the tests directory. I'm not so sure how to go about this. I'm just gonna ask. How would I go about depending on code in the test suite? And I also don't want to duplicate it, of course. Oops, that doesn't help. Okay, so I'm just gonna hope that someone has an idea how to go about this. And I'm gonna make a T. So I'll be back in a second. Wait, can I do the thing here? Wait, I'm just gonna All right, I'm back again. Let's see if we got any responses. But you could symlink the source files. Yeah, that seems a little over the top. Rather not resort to these kind of hacky things. Jimmy. Oh, hey. Hey, Jimmy. Don't let myself get distracted. Okay, I'm gonna deal with this later. For now, I'll just copy the code from the test. So I'm gonna copy the entire file. Bench. ID helper. Let's just see if that works for a second here. I doubt that this is going to work. Okay, so I'm going to move this back over here. Try this again. Well, that's probably not going to work actually. I need to rebuild everything. Oh yeah. One thing I should totally do is run this with the fast flight because I don't want the optimizations right now. Because yeah, usually when you're benchmarking, of course you want to use the optimized code, but I'm not actually interested in the any timings here right now. I only want to make sure this thing builds. Huh. So it successfully compiled ID helper. How interesting. I don't think I care about most of this. So yeah, I think I'm just going to delete most of it. Primary thing I care about is the run ID bits. Okay. So here we go. So that's what we're going to go for now. I'm going to delete all the unused imports here. Just like that. Okay, so Intero targets. Isn't that how that goes? Targets. Oh, I don't think I'm even using Intero here. Whatever. So what I want to do now is I want to import IDE.helper. Helper or helpers? No, helper. And I want to use the run IDE tick function from here with the default config. I'm going to overwrite some fields in there. Right. And I also want to import language.PureScript's.IDE.command as command. And these are the commands I'm going to send to the IDE. I might not go the command route just to cut out some middlemen and go straight, but I'd go straight and just call the IDE internal functions. But I don't think that the command parsing or any of that stuff is like anything significant time-wise, so that's fine, I guess. And then I'm gonna do the load without globs or something, whatever that is, and that's probably gonna be IO or nothing. Oh, okay, so do, and yeah. So what I'll do is I'll do run IDE tick, and I just need to look at the type here. Right, so run IDE tick. Text IDE configuration. Okay, so we're going to start with the default configuration here. And we're going to clear out the conf globs. So conf globs is going to be equal to the empty array. Just like that. So I'm going to get rid of that, and then we need the IDE state where we want to start with the initial state or something. I'm going to find out what that is in a second, and then the command is just going to be load sync. Command load sync all and everything, and then we're just going to ignore the results. I'm just going to put a void in front of this, and we should be able to do that, and then initial state is going to fail, so that's an IDE types, and that is called empty state, empty IDE state. Okay, so let's just put that in there. Oops. So empty IDE state, and we're just going to import that real quickly. What am I doing here? There we go. So I'm going to copy this line, I'm going to unqualify it, I'm going to say types, and I'm going to import empty IDE state. There we go. So that should be good, and then I'm going to do load without globs over here. We'll see what that gives me. Okay, so module IDE helper does not export the default config because I called it def config. That's a silly name, so let's just call it default config. Okay. Yeah. Talk about silly. Config. Like that. Try again. Not in scope conf globs, because that is in here, and that needs to be imported from types, I believe. So I'll just get all of the IDE config, I believe is what it's called. That might be true or wrong or right. Okay, so IDE types config IDE configuration. Nice, spelling things out. So it's telling me default configuration is still not in scope. That is true because that is default config. And I think config is fine too. Yeah, whatever. Let's just do it. Ambiguous occurrence. Okay, so that's why probably. Okay, whatever. So let's call this def config. Criterion already uses the default config name, and I don't want to bother with qualifying all of this stuff now. This is kind of this kind of stuff is just nice in PureScript because we use the explicit import a lot more, and we have IDE tooling to make that pleasant, because in Haskell land that's just super tedious. Okay, but now we are getting something. So benchmarking IDE without source globes. Let's just see how long that takes. I have no idea. And it tells me that that takes 2.7 microseconds. I don't believe you. That's not true at all, I'm sure. So we need to make sure that this stuff is forced afterwards, because that's so fast. I kind of don't believe that is true. So maybe we can just run a command .complete afterwards, which is of course going to skew the results a bit because this does take some time. But okay, I think we need a nothing in there. So okay, so match IDE declaration, and I think it's nothing and nothing. We need to pass here. I might look that up actually. So IDE command. Let's look for the complete one. Takes filters and completion options. Completion options are inside here. Okay, so let's just use another one. I guess that should be fine. We can just use a type command, I guess. So type. Let's actually just search for something that actually makes sense. So type. Let's just search for ID, which does exist. Not gonna do any filtering, and I'm not pass a current module. So this should at least run through the parsed file, the declarations. Let's see if that makes any difference time-wise. So we're still at 4.5 microseconds, which is just tiny. Kind of hard to believe, actually. Because yeah, I'm not so sure. Let me look at the config type again over here. I can pass this a log level. So what I'm going to do is I'm going to pass this conv log level, and I'm going to set that to logging. The log level, where's that? Defined, I guess, in types as well. Yeah. So I'm just going to log performance stuff. Well, okay, so that's fine now. I'm not sure if this is actually going to print anything, because that kind of stuff might actually be handled at the executable level, which we're not running the executable level, we're doing this for the from within the library, basically. Well, but I think I do have some code in there, which should actually. There's a problem that I just never care about the result. Do I need to do that or something? Do I need to make it compute the result? That's gonna give me back bytes. And that's the resulting state. And what I could do is I could force, I'm not sure if I have that in here, I probably don't, no I don't. So what I could do is I guess I could pass the state back, because I think I have an instance of enough data for that. I'm not sure though, maybe not. Let me go into ID types and check. Okay, so IDE state, where is that? That's over here. I'm only deriving show for that. Okay, so no enough data for that one. What do I have enough data for there? Don't even have it here. Okay, so I have a lot of enough data going on for all of these, all the declarations, which I kind of care about. So this is the bit I care about. So maybe I can just NF data I can just force the volatile state. So let me try that one. So what I'm going to return from here is IDE volatile state, right? And I'm going to, from the state here, I am going to just return st and then IDE volatile state. Like that. And hopefully the criterion library will then properly force that bit. So that seems to come out fine. I think I'm going to need to import IDE state there, because that's where IDE volatile state is coming from. Not in scope, IDE volatile state. Okay, so I need to add that too. And now it's starting to get silly, so I might actually start opening this import up, but then yeah, I have a bunch of names floating around that I don't really want. So no instance for NF data IDE volatile state. Is there a good reason for that? IDE volatile state. I think there is, because yeah, the AST stuff in here is not forcible probably. So I'm gonna have to grab out the declarations from there, because those definitely are forcible. So this is going to be a module, a map actually. I'm just going to do a map from p.module name to IDE declaration and okay. And now this is starting to get so silly that I will just open this import up and call this the module map. Let's see what happens. That compiles. Probably won't, because yeah, that's not actually what this is. So I'm gonna need to grab the VS declarations from there. If that is what they are called, and they are indeed. Okay, so let's do that. Damn it. Should not have done that. I knew it was gonna happen. So, I hope everything still works. I unfortunately locked myself out for a second there. So that still says that it completes in 4.59 microseconds. Can that actually be true? I doubt it, because I don't get the performance. Oops. Can I just put a trace in here? Hello. And I'm gonna make it a trace n, and I'm gonna actually just show. I'm just gonna show the state, which is nuts in a sense, but at the same time, I just want to see that something's happening here. Okay, yeah, so that explains what's going on, because yeah, that's really fast, because apparently there's nothing in there ever. So this doesn't load anything. Okay, so here we go. So why does that not load anything? Ah, of course, because it needs to be in the project, right? It needs to be in the project. So I need to run this thing in project. Well, printf debugging to the rescue. So let us see if we are going to see any output here. Does not look like it so far. That's, well, I guess something's happening at least. I'm not sure what's going on with the output being stopped. Like, I would expect trace shows all around right now. We'll see in a second. Might actually crash at some point. But okay, so something is happening. Okay, there we go. So that's good. Let's just take that one out and run this thing again, and then we can see how long that actually takes. So that's good. We're getting somewhere. And I'm hoping that I can take out the type command here, because that kind of does give the results. I don't want to perform another lookup after loading. So that, for one, did trace a bunch of this bit, which we don't really need. And, oh, so the in project, okay, so that happens all the time. That's kind of a bummer. So how about we just do the entire thing in the project? Is that a problem? Maybe we can just do that instead, because I don't see a reason to not do that. Well, I do see, well, no. Let's just try this for a second here, because we don't want the whole like switching directories all the time to be a thing, because that is kind of not super fast, I think. Maybe it doesn't matter, but anyway, we want to reduce any I/O that's not necessary. And 600 milliseconds is more, yeah, that's pretty good actually. That's around the value that I expect. Okay, here we go. So next, again, 600 milliseconds. So let's do load with globs. Okay, so for one, I'm gonna get rid of this one because I don't think I need it. See if we still get the same results. And then I might not do the whole returning this. Well, I will return the declarations because I want these to be forced, just to make sure that all the annotations have gone into these declarations, so that's good. Okay, so now we're down to 560. Okay, so the lookup was around 40 milliseconds, which is roughly what I'll expect. It's a bit slow. I think we could do better, but it's good enough. Okay, so here we go. We have that. Let's do load with globs. And of course we should not just copy stuff like this, but I'll refactor this later. So for now I'll just do this, and then the globs. We kind of want, oh wait, well, just so. Okay, so here I'm in the project. I think there's a PSC package sources or something. Okay, here we go. And we kind of want this to be, does that work? That's how it works. Damn it. And does this work? Yes, this works. Okay. So we want this. This is the package set we're working with. And this thing is totally a glob, like variable. This is variable as well. The source we want, all of that we want. Okay, so let's just use this glob. Load with globs. Put that in here, and that's gonna pull in and parse all of the files we have in the package set. And I expect that to be slower. Actually, I expect that to be a lot slower. That's kind of the problem that I'm trying to diagnose here, how slow the parsing is, the parsing part, or which part of the parsing is the slow part at some point. So at that point I'll make these more granular. But for now, just do a bit of a check here. So step bench fast again, and then oh yeah, and I definitely want to run this stuff with the optimizations turned on as well, just to see if that, like, what kind of difference that makes. Okay, so 588, yeah, that's roughly in what we expect. And now let's see what the parsing does to it. And I mean, it's not just the parsing. After we parse, we use that information, of course, and so that's also additional work that is done. And here we're at 1.9 seconds, and that is a little too slow for my taste. So I'd like that to be faster. But at least I have like a benchmark now that I can make sure does not get slower over time. Without me, like, or I can at least like spot severe regressions without too much work. So I want to break this out like module wise at some point. But I think this is for now it's very commit worthy. So I'll just do that. I'll commit this as well, whatever. That was not correct. I also need to commit my helpers. Okay, so add marks for loading with and without globs. Okay. Okay. And what we can do is we can add a few more benchmarks here where we actually benchmark stuff like completions and type lookups. But I'm not so sure if I care about that right now, because that's kind of not what I'm testing here. I think I'll just not do that for now. Okay, so, but I have some numbers here. And I'm just going to save these somewhere because I want to try something where I pull in my recent addition. Okay. Up to this. Okay, so I'm gonna open the sub. Delete this. Okay, so that works. And then I can just copy that this way. Okay, and so I'm just gonna create a little gist for me, for myself, just so that I have some numbers, and then I'm going to go back in here, and what I'm going to do now is I am going to pull from origin collect usages. I'm going to, yeah, sure. Okay, so now I merged that bit in, and I'm going to run the benchmarks again. And I still need to use the fast one because I forgot to turn on optimizations. I should run a version of this with optimizations turned on as well. Because yeah, I mean, these times were without any optimizations by GHC, which does usually make a pretty big difference, especially in the IDE code because there's a lot of fusion potential there. So while this is doing its thing, well, it's actually pretty fast. So I'll just wait. Don't want to put the VM in the background and maybe skew the results for while that's going. So okay, so we got faster. That doesn't make any sense in the sense. Doesn't matter. This part I don't expect any changes because, well, without sources I can't find any usages. But this part is where I expect a slowdown, and I want to understand how much I'm slowing down because that's kind of relevant to me. Because this is one of these operations which does do a lot of operations where if you find all the usages, that is kind of a lot of data that needs to be shuffled around. And now we're at 2.4 seconds, so that does add about 500 milliseconds, which is a huge, like that's 25% increase. So that's a lot. What I'm going to do is I'm still going to just put that up there, and I might need to run a few more of these at some point, but I think this is kind of like the difference is so clear that it doesn't really matter. So this is with correct usages, and this is master. Okay, so I have an idea of this being slower or faster, or how much slower or faster it is. And okay, so that looks horrible. So I need to put this in there. Do the same thing here. Here we go. Okay, so yeah, this is the bit that I care and worry about. Anyway, it seems to be working because, yeah, obviously it measured the slowdown. So I think I might actually, well, for one, what I'm going to do is, of course, I'm going to get back to the state before I merge any of this stuff, which is up here to this point. So I'm going to go back here, heart, to 5.8 A1CA 70. Huh. How do I do that again? Wait a second. What I want to do is I want to basically get rid of all of this stuff. I want to jump back to this point. Does this work? Let's find out. All of these are changes. Yes, I think that's fine. So yeah, I don't want any of these changes, and I don't want any of these changes. Yes, please. And now I'm back to... Yes, okay, so now I'm back to where I want to be. That worked out well. Okay, so I'm going to push this to my repository. And I think what I'm going to do is I'm going to think about how to organize this and clean it up in a way that we can add benchmarks for other parts of the compiler, like the actual compiler. But I don't really know how to do that yet. And I think I'm going to do something else for now. I'm going to play some chess, I think. So yeah. I hope that was helpful, or interesting at least. So if you want to how to set up a benchmark suite, well, for one, use Criterion, and to check out this video. Great. Have a nice day, everyone.